In this video, I have been asked to find the formula of a trig function based off of a graph. This graph in question is seen here, having a maximum of 1.5 and a minimum of 0.5 every period, as you see here. Now, first thing I need to do is determine whether this is sinusoidal or cosine or tangent or whatever function we are trying to find. Now, I've decided that this is a sine function because it has a y-intercept of 0.5, when a cosine function, y has to be 0 when it crosses the y-intercept, due to the fact that cosine starts at a maximum and falls, which this does not. So this is a transformed sine function. First thing we need to figure out would probably be the amplitude as well, and as I can see, it goes, the difference between 0.5 and 1.5 is 1, meaning that the amplitude needs to be half of that. So it goes up by 0.5 and down by 0.5 when y equals 1, if we had a pretend line going through here. And that means our amplitude is 0.5. So, first of all, a sine formula is a sine, with k being the period and x being the variable, and then we have d being how far it is shifted, if it is shifted, and then c is whether it is shifted up or down, which it definitely is, because if it was not, then the midline, the middle area that the amplitude goes up or down from, would be at 0, which it is at 1. So we already know that c is 1. And let's assume that there is no shift. So we will go along with k times x just to simplify things a bit. And if we do find that there is a shift, we will find it at the end. So plug in what we know. An amplitude of 0.5 sine kx plus 1. Now we need to find the period, or k, and period is 2 pi over k equals the period number we already know of 2. And we know it's 2 because when y equals 0.5, that is the beginning of one cycle, and it equals 0.5 again when x equals 2, meaning this section here is one cycle. Happens again between 2 and 4, and then we assume it would be the same for 6 and 4. So it is definitely 2 for each cycle. So we would then have this equation here, and we solve for k. And what we do is we find the reciprocal of each of these numbers, which is k over 2 pi equals 1/2 times 2 pi. And when you have something times 2 pi, you end up finding the value of this divided by 2, or 1, and anything above 1 is itself, so k equals pi. Which means, if we move on, we currently know that y equals 0.5 sine times pi, the sine of pi x, plus 1. And we want to test that, just to be sure if there is a shift or not. And when we go on to the next slide, if I can aim, there we go. we have it all plugged in here, and I have, just for simplicity's sake, so you can see where things line up, I have x equals 2 in orange, y equals 0.5 in green, 1.5 in blue, and 0 in purple. And as you can see, this does not line up with the same graph we had at the beginning. So that means that this needs to be shifted over this way by a certain amount. And just for simplicity's sake, the value of this is 0.5 less than it should be to line up with this. So this whole graph needs to shift over 0.5. And so we move on to step 5, where we establish where a shift would fall into this data, because x needs to shift, but pi does not need to change, k does not need to change. So we plug in d for a shift to the right, or negative 0.5. So we now have this equation of 0.5 sine equals to pi times x minus 0.5 plus 1. And we can graph that again to see if it matches up. And sure enough, 0.52, because the green and the orange and the red all line up at 2. Same for 0, 4, which is off to the side here, and negative 2, the same as we see here. So that means that our equation must be correct. We could also have just plugged in the data if we found that that would make it a lot more easier to tell. So just to zoom in, we have just my worksheet here with all of my data and all of my work. I hope you found this helpful.